So on Wednesday, after you took your quiz, hopefully you went through that ionic bonding tutorial. I just want to tie up the really big ideas of ionic bonds, okay? So the big idea for ionic bonds is electrons are taken, okay? So the big keyword is taken. So highlight, star, underline, taken, okay? So one atom is going to steal the electrons from another atom. And then at the end of that tutorial, I posted a video of how do we draw Lewis structures for ionic compounds. We'll draw potassium oxide together here so we can practice as well. Okay. So whenever we want to diagram atoms bonding, we draw the diagram. We call it a Lewis structure. You might see it as a Lewis diagram or a Lewis dot diagram. Okay. It's all the same thing. So we're going to draw potassium oxide. Okay. The very first thing we have to do is write the formula. Okay, so what's the symbol for potassium? Okay, and what's the charge of potassium? +1. What's the symbol for oxide? Oxide is O with a -2. And then what do you have to do with those charges?
Crisscross.
Crisscross. So what do we get as the formula for potassium oxide? Okay. K2O. So you have to do this step first. The reason is, by writing the formula, you now know the quantity of atoms. Okay, so we now know that there's 2 potassiums and 1 oxygen. Then we're just going to draw the atoms. Typically, you put the single atom in the middle. Okay, so there's 2 potassiums and 1 oxygen. So since there's 1 oxygen, I'm going to put oxygen in the middle. And then potassium on each side. All right, so how many valence electrons does potassium have?
1.
Okay, 1. So I'm just going to draw a little dot. That's the valence electron. This potassium also has 1 valence electron. How many does oxygen have?
6.
Okay, 6. So I'm going to put 6 dots around oxygen. Now, what's the magic number of valence electrons atoms want? 8. They want 8. So what happens is, in an ionic bond, one atom's going to steal the electrons from another atom. So which one do you think is going to steal the electrons? Oxygen. So oxygen's going to take an electron from each potassium. So now I'm just going to rewrite it below. Okay, so potassium lost an electron. So it drops down. Does potassium now have a filled shell? Just a lower energy level? It's a filled shell. It's happy. It's stable. Because potassium lost an electron, what kind of charge does it have? Okay, so potassium gets a plus charge, and I'm not going to draw any valence electrons because I want to show that it lost one. Oxygen has now gained 2 electrons, so it now has a total of 8, and it gained 2. So what kind of charge does oxygen get? Okay, it gets a -2 charge. And then potassium is the same as the first one, so it lost that electron, and it has a plus charge. Okay. All right, so then this is our Lewis structure for potassium oxide. Okay, so this is how we show the bond there. What do we know about positive charges and negative charges? They attract, okay? Notice there's nothing physical holding these atoms together, right? We didn't draw a line showing that they're somehow connected. What holds it together is the attraction of these charges. So these positives are attracted to the negative, and this makes a very strong bond, okay? It's a very strong bond. It takes a lot of energy to break that bond. Take a look at your periodic table. I want to refresh. How do we know how many valence electrons the atoms have? Okay, so everyone look at your periodic table. If you have a blank one that you can write on, write these numbers with me. Okay, so the first column, these all have 1 valence electron. The second column has 2 valence electrons. Then I'm jumping all the way to boron's column. Those all have 3. Then it goes 4, 5, 6, 7, 8. Okay. So while we draw Lewis structures, we need to know how many valence electrons each atom has. You're going to grab that number from whatever column you find them on in the periodic table. You with me? Okay, so write these down. Do you have those numbers written down? Okay. So today we're going to talk about covalent bonds, and we'll learn how to draw Lewis structures for covalent bonds. Okay. What you need to know about covalent bonds, these form when electrons are shared between 2 atoms. So the key word for covalent is you're going to share electrons. And you share a pair. What is a pair? 2. Okay, so 2 electrons are shared. Okay. Covalent bonds form between covalent compounds. So typically your nonmetals. And so an example is hydrogen. Okay, so hydrogen is found with 2 atoms bonded. So we have H2. Each hydrogen has 1 valence electron. So then they share those valence electrons. So they get close enough together where both of these electrons are in both of their valence shells. Okay, so what holds these 2 atoms together is they have to be close enough so those valence electrons overlap. So covalent bonds form when atoms share electrons. Atoms can share more than 1 pair. Okay, so you can have something called a double bond. So a double bond is when you have 2 shared pairs. How many is a pair? Okay, a pair is 2. So if you have 2 shared pairs, you have 4 electrons being shared. So the way we write double bonds is typically like just 2 dash lines. Okay, so if you see 2 dashes, that's what we call a double bond. But you're really sharing 4 electrons. Does that make sense? So 2 shared pairs is 4 electrons. You can also have a triple bond. So a triple bond is when you have 3 shared pairs. The way we write it is the 3 dash lines, just like we see right here. And a pair is 2, so if you're sharing 3 pairs, you're sharing 6 electrons. So if you look here, do you see how now 6 electrons are being shared? Okay, so as we draw Lewis structures for covalent compounds, we can draw single bonds, double bonds, and triple bonds. And as we work through Lewis structures, you'll like start to learn how do you know which one you use. So on this slide, I'm going to show you how we write Lewis dot diagrams for covalent compounds. I don't think you need to write the steps. Okay, I have them here, but we'll just do this example together, and as long as you do the examples with me, you'll understand the process. Okay. So what we're going to do, first you have to count all the valence electrons. Then we're just going to draw the atoms. And we just start placing electrons around each atom until we fulfill the octet rule. What is the octet rule? 8. Okay, so all atoms want 8 valence electrons, except which atom only wants 2?
Hydrogen.
Okay, hydrogen. Helium also only wants 2, but does helium bond? No, so you're not going to see helium. But hydrogen wants 2, everything else wants 8. Okay. When you draw pictures, we do have to know which atom becomes the central atom. The easy way to remember it, I call it the odd guy out. Okay, so the odd guy out, for example, if we have CCl4, how many carbons are there? 1. How many chlorines? 4. So which one's the odd one out? The first carbon, right? If you have 1 carbon and 4 chlorines, that 1 carbon is the odd guy out. So that's the one that goes in the middle, okay? So that's the rule I tell people because I think it's easier to remember. The official chemistry rule is the least electronegative element goes in the middle, okay? Those two, they coincide, okay? The odd guy out is the least electronegative. Okay, so we're going to do the example together. If you follow along the example with me, I don't think you need to write those steps. So step 1, we have to count the valence electrons. So we're going to use the columns we wrote down at the beginning. So how many valence electrons does carbon have?
4.
4. Okay, how many does chlorine have?
7.
Okay, and how many chlorines are there? 4. So I'm going to multiply that by 4. And then we just add them up. So what's 7 times 4? 28 plus 4. Okay, so when carbon and 4 chlorides bond, there's 32 valence electrons that participate in that bonding. Okay, so when we draw our Lewis structure, we have to show where all 32 electrons are going. All right, so then the next step is we got to figure out which one goes in the middle. So what's the odd guy out? Okay, so carbon goes in the middle, and then I just spread out the atoms kind of like evenly around. All right, when you draw a line like this is just a single bond. How many electrons are in a single bond? 2. It's a pair, so a pair is 2. So we've used 2 electrons here, 2, 2, and 2. So we've used 2, 4, 6, 8. You with me? Then off to the side, I keep a tally of how many electrons I've used. So I started with 32. I already used 8. So how many do I have left? Okay, 24. So then now the name of the game is fulfilling the octet rule. And what's the magic number for the octet rule? 8. I recommend you start with the outside atoms. Okay, so start with the outside. We'll start with this one. How many electrons are in this bond? 2. Chlorine once, how many total? 8. So how many do you have to draw around it? 6. When we draw electrons, we keep them in pairs. And so we just draw dots. So when there's just 2 dots alone, we call that a lone pair of electrons. Lone means it's not bonded, and a pair is how many? 2. So we draw a lone pair on the top, a lone pair on the side, and then a lone pair on the bottom. Okay. So how many electrons did we just draw? 6. Okay, so I'm going to subtract that from my tally. So how many electrons are left? 18. All right, then this chlorine has how many electrons here? 2. So how many do we have to draw in? Oh, okay, we got to draw in 6. We got to get to 8. Okay, so I'm going to draw in my lone pairs. I have 12 left. Are all of the chlorines going to be the same? Okay, so this chlorine has 2. I'm going to draw in 6. I have 6 left. And then the top one, I use 6. I have 0 electrons left. Okay, so we have to go till we have 0. But then I also have to check my central atom. Carbon wants how many? 8. And how many are in a line? 2. So it's used 2, 4, 6, 8. So have I fulfilled the octet rule for all of the atoms? Okay, so this is how you know you're done. So each of your atoms have 8 electrons around it, and you've used every single electron. We're going to do 3 more practice problems together, and then you'll do some on your own. Okay. So we'll draw one for water. What's the formula for water? Okay, so water is H2O. The first step is counting valence electrons. How many valence electrons does hydrogen have? Hydrogen has 1. And how many hydrogen atoms are there? 2. So I'm going to multiply by 2. And then how many valence electrons does oxygen have? 6. So how many total? 8. Okay. Next step, we just have to draw the atoms. Which one do you think goes in the middle? Hydrogen or oxygen? Which one's the odd one out? Oxygen, there's only one. Hydrogen will never be in the middle. Never, ever. Because how many valence electrons can hydrogen have? 2, so it can never have more than 1 bond. Okay. All right, so I started with 8 electrons. How many electrons have we used in that first shared? Okay, so we've already used 4. So how many are left? 4. Okay, then we figure out the octet rule. Always start on the outer atoms. Hydrogen wants how many? 2, and how many are in the line? 2. So hydrogen is done, okay? Then we look at oxygen. How many has oxygen used in the lines? 2, 4. Okay. And how many does oxygen want to have? 8. So we have to draw in how many electrons? 4. When we draw them, we always keep them as a lone pair. Okay, so there's 2 on the top, 2 on the bottom. Okay. We've used all of our electrons, and have we fulfilled the octet rule?
Yes.
Okay, so we're done. So that's what water looks like. All right, next is ammonia. Ammonia is NH3. Thank you. If I wasn't here to tell you ammonia's formula, where could you find it? Internet, right? Internet, your naming chart. Okay. Ammonia is NH3. How many electrons for nitrogen? Nitrogen has how many? Okay, 5 for nitrogen. How many for hydrogen? Okay, 1. How many hydrogens are there? Okay, so 8 total. Which atom is going to go in the middle? Okay, nitrogen goes in the middle. And then I just spread them out. Okay, spread out your hydrogens. Okay, we started with 8 electrons. How many have you already used in the bonds? 6. So how many electrons are left? Okay, so 2 electrons are left. Hydrogen, do you need to add any more? They're good. They only want 2, they have 2. Nitrogen has 2, 4, 6, and how many does nitrogen want? 8, so you got to add in 2. So again, you add them in as 2 dots. What do we call those 2 dots? We call them a lone pair. Okay, a lone pair. We've used them all. Okay, last one. Try methane on your own. Methane's formula is CH4. Okay, so try to draw methane. How many total valence electrons in methane? How many total valence electrons? Okay, 8. Which atom goes in the middle? Carbon. Okay, you start with 8. You used 8. Was this one kind of nice and easy?
Yep.
Okay.